SF 5.1 limits, slopes of curves. So limits, we have seen limits a couple of times in the IB Diploma Mathematics AA curriculum. So such in the functions, we saw graphs that approach an asymptote, and this is the limit of the f of x. So what this means, when you have graph like this, let's say this is f of x graph, we get asymptotes, right? So in this case, we have a limit. Also, another case that we can consider is the ones that the limits of the sum of the geometric sequence, such as the R value. We know that R value always has to be less than 1, right? In both of these cases, we never actually reach the infinitely close and never go beyond it, right? So also the limits will be very important in calculus. So to understand what happens when these numbers that infinitely close and never go beyond the line or the limits, we use the mathematical principle called the limits. So here are the definition of the limits. Okay, so if f of x is close to, as we like to some real number a, for all x sufficiently close to but not equal to a, then we say that f of x has the limit of a as x approaches a value, then we write these equations. Okay, in this case, f of x is said to converge to a as x approaches a. So let's do an example. So let's do this example number 1. So we wish to find the limit of the x squared plus 3x over x as the x approaches 0. So I'm going to call this x squared plus 3x over x as f of x, function f of x. So function f of x equals x squared plus 3x over x. And then we were trying to find the limit of this function as the x approaches the 0. So it is very tempting to substitute x equals 0 into the function f of x. However, in doing this, not only do we get the meaningless value of the 0 over 0, but also we ignore the basic limit definition. So this is not working. Okay, so the proper way of solving this limit is we know that if f of x is equal to x squared plus 3x over x, this is same as x times x plus 3 over x, right? And this gets simplified, okay? Then we can say that then f of x is x plus 3 is possible if the x is not equal to 0 or is undefined if x is equal to 0, right? So the graph of the function f of x is therefore then we can say the limit as x approaches 0 of x squared plus 3x over x is 3. Okay, so the good thing about the limit is we actually evaluating the limits requires some more advanced mathematics, but we will actually just learn rules for the various types of functions in Excel, and that's it. Okay, so then let's talk about the slopes of curves. So the first question that we need to consider with this diagram regards the slope is, what is the slope of this curve? The answer is it varies, depends on cases, but this is still quite complicated as we are now learning the limit, okay, the concept of the limit. If we want to calculate the slope of this function, right, if we are doing as previously in function, we need to find another point on this diagram called the x1 plus h and have to find the slope between these 2 points using the y2 minus y1 over x2 minus x1 equation, right? However, since we are learning the concept of limit, it is no longer very accurate. So we need to move x1 plus h closer to the x1 value and create a straight line out of it. Okay, so when we do this, we get a tangent. So when x1h gets closer to this x1, now the line is almost meeting the function at one point. So now we have a tangent line. Okay, and we need to calculate this gradient of this tangent line as the slope of the function. Okay, so the gradient of the tangent formula. So gradient of the tangent is actually is the same as the derivative of function. Okay, or differentiation from the first principle. However, if we want to calculate the gradient of the tangent using the limit formula, this is the formula. And also, as I told you before, we never really going to use the concept of the limit to calculate the derivative of a function, but we're just going to use the first principle rule. So let's try with the example number 2. I am just going to use the first principle rule, okay, the derivatives. I'm just going to calculate the derivatives of this function f of x, okay. So derivative of the function f of x is same as 5 times 4 times x to the power of 4 minus 1 plus 1 times 2 times x to the power of 2 minus 1, right? This is same as 20 times x to the power of 3 plus 2 times x to the power of 1, right? And the gradient of the tangent is happening when x value is equal to 2. So we just have to substitute 2 into our derivative. Then we get 20 to the power of 3 plus 2 times 2 equals to 164. So this is the gradient of the tangent of the function f of x. So now let's talk about the notation. When we have a function, the gradient function is called the derivative, right? Or the gradient of the tangent is actually a derivative, right? So if we have a function f of x, then derivative format is the f prime x. If we have a function y, then derivative format of the function y is same as dy over dx.